Benchmark 2C, graphing systems of equations and inequalities. So let's graph and find the solution to these two equations. The first equation right here is ready to graph. But for some of you, you might want to put a plus 0. You don't have to, but you need to know that. You also might want to put a 1 there. Don't have to, but you might want to. So that means I begin at 0. And what's my slope? 1. Which means I go up 1 over 1. Now, I could keep doing that. When you're trying to find the solution by graphing, you want to make your graph very accurate. So I'm going to make a nice straight line, get as many dots as I can. Now the second one, that is not in proper form. So if I want this to be y equals, do you understand the first step will probably be to add the 3y over this way? And I now have 3y equals, I'm going to switch these two. I'm actually going to put a 1 in front of the x. The negative x is now negative 1x, which is the same thing. And the 12, I rearranged it so it's in a better form. Now, our next step would be probably to divide everything by 3. That's gone. I now have y equals negative 1 divided by 3 does not reduce, so it's just negative 1/3 x. And 12 divided by 3 is positive 4. So that means I am going to, for this particular graph, where am I going to begin? At 4. And my slope says I'm going to go down 1 and over 3. So down 1 over 3, oh, I got a nice little hit. Make my line. And where does it hit? That looks like over 3 up 3. Is that right? Make sure you put the coordinate where it hits. That is the solution. The coordinate where these two graphs hit is at 3, 3. This problem is pretty much the same idea. It's just you have to shade. And you don't care where they cross, you care about where the shade overlaps. So for the first one, I'm going to do in blue. Y is greater than or equal to negative 1. So first put a dot at negative 1 on the y. Now, if it's greater than or equal to, you should know that's a solid line. That's y is always negative 1 there. And if that's is greater than or equal to, what you have to realize is you're shading the top of that line. Greater than or equal to is the top of the line. Less than is below. The next coordinate, x is less than 2. So you go to x and put a dot at 2. Now, it's just less than, so it's not a dot, it's not a solid line, it's only dotted. That value, x is always 2 there, but it's dotted because it's just less than, not less than or equal to. And less than means the lower values, and on this line, the lesser side is this side. That has the smaller values. So on this side, we're going to shade. So we lightly shade. So if we stop right there, do you see your answers right here? There's your answers if we stopped. But we still have one more graph. So my last graph, to get this, I first need to change the form. So I'm going to add the x over. Probably want to put a 1 in front of that x. Then it looks like I'm going to divide by 2. So I have y. Does the sign flip? We did not divide by a negative, so it stays. 1 divided by 2 is 1/2 x. 2 divided by 2 is 1. So let's graph this one. I'm going to do it in green. This one begins at 1, and it looks like it goes up 1 over 2. So up 1 over 2. And it is a dotted line because it's just less than. And it is less than. So if I put my arm out, it's this arm. Less than's the bottom. Less is the bottom. So if we shade this, you do less than. Now, where do you see all three basically overlapping? Even though I don't have green in here, what you'll notice is between all of these, it looks like it's right in here. So the goal in the end is to darken your answer. If you do not darken your answer, it's like you didn't circle your answer, and I might not give you credit. I want your answer darkened so we know what is that solution. What is the point where they overlap? What is the area of overlap? So these you shade. Make sure you watch out for dotted and solids. This you just graph and find the exact spot. You must be very close on this to get your credit.